So here we are. We are at the step where calcium is released out of the sarcoplasmic reticulum. We understood that this is because of the action potential traveling down the T tubule and cause the calcium to get out of the SR. In order to understand where is the calcium now is going, we need to go back to check the actin and myosin. So I'll move a couple of slides or several slides back, all of the way to here. Now, I wish there is a way to zoom this. There is no way to zoom this more. Okay. Now, we said the actin is these beads, okay, with the binding side, and the myosin is or the myosin has these heads that are going to fit on the actin. But I need you to look very carefully here, or look carefully here. On the binding side, there is this line, and then there is this pole. This line is another protein. It's called tropomyosin. This tropomyosin acts as a barrier. What does it mean, barrier? It's a physical barrier. It means it blocks the heads, the myosin heads, from getting inside actin. Okay? It blocks the heads from getting inside actin. So if the actin is like this, right? This is the binding site. This area is the binding site. Here is the binding site. And beneath it, we have the head. The head should go inside. Now, the problem is, if the head goes inside, we will have contraction, right? But sometimes we don't need to contract, like we need to sleep, we need to relax. Not every muscle has to contract all the time. But if the head goes inside, if the head keeps going inside, that would lead always to contraction. If the head keeps going inside, that will always lead to contraction. So to prevent the head from going inside, we are going to put a bar to physically block the head from going inside. Okay? To physically block the head from going inside. This bar is called the tropomyosin. Okay? This bar is called the tropomyosin. Now you might ask, okay, how then, if this is the case, how then the head will get inside the actin when the muscle needs to contract? It turned out that the location of this tropomyosin is controlled by the other protein, by this pole. By this, I will put it in a different color, by this. These are proteins, another protein called troponin. And troponin, its function is to controls the location of tropomyosin. To control the location of the tropomyosin. What does this mean? Let's go to OneNote. Now, I need you to think when you are driving your car, okay, this is you driving the car, okay, and you are coming to a parking lot. So here there is parking lot, okay, but this parking lot has a gate. right? So this bar is prevents you from getting inside, unless you pay like some money or you get a ticket from here. Once you get the ticket, the bar will open, so you can go inside. Oops, that is so big bar. Okay, so once you get the ticket, the bar will open and you will be able to go inside. I know this is not perfect drawing, but anyway. Right? So this is exactly what happens with the myosin head and the actin grooves. The bar or the tropomyosin was moved away. How? By the troponin. So the troponin acts as this the engine or the motor of this bar. Troponin. Now with this motor, because you got the ticket, the motor moved the bar away. But here, what caused the troponin to move the tropomyosin away is actually the calcium ions. So calcium ions, once released from the SR, Once the calcium ions released from SR, they will come and bind to troponin. Troponin will change its shape. Because of this change of shape, tropomyosin will move away from the binding site, and now the head can go inside the groove. And this is exactly what happens here. Let's see it. I will add a couple of other YouTube videos that will explain or show you like with animation how this is happening. But this is exactly how it looks like. So here, this is at rest. As you can see, troponin, because of the location of the troponin, tropomyosin is blocking the head from going inside. Once calcium is released, it will bind to troponin and it will cause it to change its shape and move tropomyosin away. So now the actin is ready to move up and bind the myosin head is ready to move up and bind the actin. Good. Again, I will stop here. I need you to go over this and absorb it before we move and talk about how the actual contraction is happening.